Hello and welcome to Walking Talking Mocks with Budehaven Science. This video is going to look at rates of reaction. We will cover the subject knowledge you need to answer a question like this. You will then be given the opportunity to answer an exam-style question, followed by an example answer from me. Here is the question. In order to answer this 4-mark question, you will need paper, a pen, and something to time yourself with. To answer this question, you will need to have a good understanding of how certain conditions alter rates of reaction. For your course, you need to know how temperature, pressure, concentration, and finally, surface area affect the rate of reactions. If you are a triple science student, I will do a separate video for dynamic equilibrium and altering conditions. When discussing rates of reaction, you're considering how quickly reactants form products. There are 3 common techniques to measuring the rate of a reaction. Measuring the decrease in mass over time, measuring the volume of a gas formed over time, and measuring a decrease in light passing through a solution over time. When a reaction takes place, the reactants must collide with sufficient energy for the reaction to occur. This idea is called collision theory. This means there's a minimum amount of energy the particles need in order to react, and we call this activation energy. You will have looked at this during your topic on endo and exothermic reactions. So thinking back to the 4 conditions, temperature, pressure, concentration and surface area, we will consider how a change in each of these will impact the frequency of collisions and the amount of energy the particles have. This is because an increase in collisions and energy results in an increase in rate of reaction. To begin with, let's consider the effect of altering the surface area of one of the reactants. If you imagine a reaction taking place between an acid and a metal, in one test tube we put 10 centimeters cubed of acid and 2.5 grams of a solid metal. In the second tube, again, we use 10 centimeters cubed of acid, but we add 2.5 grams of powdered metal. Assuming the acid isn't the limiting reactant, which metal will be used first? If you guessed powdered metal, you are correct. This is because when a reactant is powdered, more of the particles are in contact with the other reactant, in this case the acid. The whole piece of metal will not react as quickly because only its surface can react. The metal atoms inside have a long wait before they come into contact with the acid. So looking at the diagram, imagine each square on the grid represents an atom. There are many atoms inside the piece of metal that are yet to react, whereas the powdered metal, no atoms are waiting to react. Next, we can look at the effect of temperature. When the temperature of a reaction is increased, the rate of the reaction will also increase. This is because more of the atoms within the reaction have sufficient energy to react, i.e. enough activation energy. As well as this, the atoms are moving faster, meaning there is a higher frequency of collisions. Both of these factors contribute to reactants turning into products faster. The next factors to consider are concentration and pressure. Although these are slightly different, the reasoning behind how they affect the rate of reaction is the same. So if we consider concentration first, concentration is how many particles are present in a set volume. If the number of particles increase and the volume stays the same, the concentration is higher. Using the school corridors as an analogy, if the corridors are quiet due to there being a low number of people there, it's highly unlikely that you'd bump into someone as you pass them. However, when the corridors are busy, they can represent high concentration. In a higher concentration, particles are more likely to bump into one another, so increasing the frequency increases the rate of reaction. Similarly, an increase in pressure forces the particles closer together. This will increase the frequency of collisions and result in a faster rate of reaction. With both concentration and pressure, only the frequency of collision changes. There's no impact on the joules of energy of the particles. The topic of concentration and pressure in rates of reaction has a required practical link to it. Therefore, you should fully understand how to investigate this. I will do another video on investigating rates of reaction and calculating a reaction from a graph. The final factor to consider is the use of catalysts. You will have looked at catalysts in your biology course in the form of enzymes. In chemistry, we consider catalysts such as transition metals. One form of a catalyst that you use in your daily life is a catalytic converter in a car. Catalysts are very useful in industry as they can reduce the temperature and pressure needed to run a reaction at. Creating an environment at high temperature and pressure can be costly, so using a catalyst can reduce a company's costs. A catalyst is unique in its way of altering the rate of a reaction, as it does not increase the frequency or the energy of the collisions. The way in which catalysts increase the rate of a reaction is by providing another pathway to make products. So instead of just relying on the successful collisions, products can also form using the catalyst. Another benefit of using catalysts is that they are unchanged after a reaction. Although it might seem simple that as these factors increase, so does the rate of a reaction. The more challenging, and therefore the knowledge that will give you the most marks, is explaining why this happens. Now it's over to you. You have the opportunity to answer this 4-mark question. State the effect that increasing the temperature will have on the rate of a reaction. Then, explain this effect in terms of particles and collisions. Pause the video now for 4 minutes and attempt your own answer. For this question, the first thing I need to do is identify and state the effect of an increase in temperature. Thinking back to the subject knowledge, we know that higher temperature increases the rate of a reaction. The next thing is to explain. So this means I need to give reasons for the increase of rate of reaction. Increasing temperature increases the energy, so more of the particles have enough energy to react. As well as this, the frequency of the collisions has increased. Therefore, the reactants become products quicker. So here is my answer in full. If you're still struggling with this topic, see your teacher or come to one of our Wednesday revision sessions.